Brant DXT grain carts have efficient unload speeds, large carrying capacities, unmatched durability, and reliable components that make sure your cart is working when you are. Lead the field with DXT grain carts from Brant. Visit your local Brant dealer for more information.
I'm Amber Bell, and this is Real Agriculture here today at Ag in Motion in Saskatchewan. Speaking with Jeremy Irvine, who is a PhD student with the University of Saskatchewan. Welcome, Jeremy. It's great to see you.
Yeah, perfect. Thank you so much.
Okay, so you have been working on a project. You're within the entomology department. What was your project with?
So I work in agricultural entomology, but specifically in forages. So I work in red clover and red clover seed production. My project is around this one pest, the lesser clover leaf weevil, and it's a very bad pest and causes 50–60% yield damage year to year. And I'm working at reducing the amount of insecticide applications it takes to control this pest.
How widespread is the lesser clover leaf weevil?
So it's anywhere that red clover or other clovers are actually grown. It's also a pest of white clover and alsike. But a lot of that production is in northeastern Saskatchewan, the Peace region in British Columbia, and then in Oregon in the United States.
Okay, and what damage is it actually doing within production systems?
So it can cause a lot of yield damage. So up to 50–60% we see in some years. And this is because it's the larvae. So when they feed, it eats the vegetative plant growth. As the plant is growing, it's eating that. So you're losing some yield potential because the plant has to keep growing. And then once that plant switches over to reproductive growth and it wants to develop flowers and seeds, the larvae will also start to eat those developing seeds. So you get a huge yield loss there as well.
Right, and we're talking about yield loss. However, there's other damage that's happening to other pollinators and such. Can you talk about that a little bit?
Yeah, so red clover is self-sterile, so it can't reproduce with itself. It needs some sort of cross-pollination. Most of that is from insects, our native pollinators such as bees and other pollinators. So when we're applying insecticides to this pest, we're also damaging those native pollinators, which again will reduce our overall yield potential. So what my project is really trying to do is to reduce the amount of insecticide applications we have so that the native pollinators can flourish. We still get a good amount of pollination from them. But also then when we do apply insecticides, we know we're doing it at the right time. So we have a good amount of control of the insect without hurting those beneficial insects we have in the field.
And how far along in the project are you?
Right now, we just finished up developing economic thresholds and sequential sampling plans. And now I'm working on a chemical ecology aspect where we're trying to develop a pheromone that will attract the males to a specific an area that where we can trap them and kill them. So they won't be able to reproduce with the females, and then the females won't lay eggs, so we can disrupt that life cycle.
Where can people go for more information?
To our website. So if you go to USask Ag Bio, you can look at the entomology lab to see all the research that's going on, or on Twitter at the Prager Lab on Twitter or any other social media.
That's great. Well, thank you so much for your time. And that was Jeremy Irvine on Real Agriculture.
Perfect. Thank you.